iso or hypertonic, isotonic. It means you can be more than, less than, or the same as something you're comparing. You can also compare osmolarity, right? Both things can have 200 millimoles of solute. But because the concentrations can be different, you can be isoosmolar, but hyper or hypotonic. All right, so I'm going to say this one again because it's really important. Tonicity is a relative term. You cannot be tonic in any type, isotonic, hyper, hypo, unless you're comparing it to something else. Hyper means more than, hypo means less than, and iso means same as. Those are comparative terms. Unless you're comparing something, you have no way to use them. Osmolarity is an independent judgment. It's just number of things in this liter of solution. Tonicity is relative. So I'm telling you this because it's important, but also because this has definitely tripped people up on quizzes and exams that I've given this to in the past a lot. If you're not comparing it, it can't be a thing. So here we have a cell, and here we have solution. So I'm going to give you a couple of different conditions, and we're going to figure out what happens to this cell in condition. So condition A. Okay, so there is more. All right, so given, we're talking about osmosis, which is the movement of water. Water is moving. And that's an L for the phase. Okay, so given there is more sodium inside the cell than outside. So that's a higher sodium concentration inside. Okay, so what's true about that in this condition? One, what's true is the osmolarity just for sodium is higher inside a cell. Does that make sense? If you're just considering the moles of sodium per liter of solution, if the osmolarity just for sodium, not for all solutes, but just for sodium, if I say the osmolarity of just sodium is higher inside the cell than out, then you know that there's a higher molar concentration of sodium inside than outside the cell. Okay? The total osmolarity is unknown. So if you get a problem like this, unless I tell you what the total osmolarity is for either one of these, you have no idea. I have to tell you because you could, what else? Unless I say there's nothing but sodium and water, how else would you know what's in there? All right? So number 3, water will move from solution into cell. I know this because water moves from an area of low solute concentration to an area of higher solute concentration. Given that the solute can't move, we're only moving water. The only way to make these things equal is to move more water to where the concentration is higher. Because the concentration, right, if you have 100 molecules of sodium, or ions of sodium, in a gallon of water, and you have 100 ions of sodium in the ocean, the concentration of ions in the ocean is much smaller than the concentration of ions in the gallon of water. Does that make sense? Like if you have the same number of ions, I've got 10 sodium ions in my 8-ounce glass, and I've got 10 sodium ions in my gallon of water, even though the total number of ions is the same, the concentration is less. Okay, so water moves from an area of lower solute concentration to an area of higher solute concentration. That means that the water is going to go move to try and dilute the higher sodium concentration area. It just goes in that direction. So that's why I know that water will move from the solution into the cell, because low concentration. Okay, so what happens when that happens? So that's fine up to a point, but our cell can only take so much water. If too much water moves in, the cell's going to burst open. That's cell lysis. There is no way, aside from shutting down all the water-moving channels like the aquaporins, there is no way to stop this water moving in, because this is a semi-permeable membrane and we're going to assume right now it's permeable to water. There's no way to stop it. So the water's just going to move in until the cell explodes. Too much water. So cell will now, which one is hypertonic and which one is hypotonic? Putting it together. So hypertonic means higher concentration. Hypotonic means lower concentration.
Of the solute, right?
Yes. And isotonic means same. All right. So, in this example, example A, is the solution hypertonic or is the cell hypertonic? Which one has more? The cell, right. So this is hypertonic, and you always have to say to what? To solution. Which one is hypotonic?
Solution.
Right.
To the
Hypo to cell.
So all we have to know is number 3.